In this video, we will be simplifying some exponential expressions, being careful not to leave any negative exponents such as these. Now, on number 13, it might be tempting to multiply these 60s together and get 36, but don't do that. 6 to the 5th power is 6 times 6 times 6 times 6 times 6. No matter what we do, we're dealing with a bunch of 6s. We don't want to change these into 36s, so do not multiply 6 times 6. What you will do when you're multiplying with exponents involved, you add the exponents. So this is going to be, if you do 5 plus negative 2, that is the third power. Now we've decided that if something is squared or cubed, we're going to go ahead and do it out. If it's fourth power or higher, we're going to leave it. So we'll go ahead and put this as 216. All right, now looking at number 14. Now the 3x to the third power has an exponent of its own. This first part doesn't. So we're going to leave the negative 3x squared out of this for the time being. So we have to do 3 to the 7th power, which we will just have to leave as 3 to the 7th power. And then when we do x to the third power to the 7th power, we multiply these. So that'll be 21. So this is what we have so far. Now we need to multiply this together. Now it might help you to think about this as 3 to the 1 power for what I'm about to do. This negative sign is just going to stay out front. All right? It's sort of like a negative 1 that does not get involved in this. But anyway, I'm not going to put the 1. So if I have 3 times 3 to the 7th power, that is 3 to the 8th power. I'll put the 1 there to help you see that. X squared times x to the 21 power is going to be x to the 23 power. So this will be the final answer for number 14. That negative just sits there in front the whole time. It's fine. Now let's look at number 15. Okay, hold on. Yeah, looking at number 15. Now both of these parentheses have exponents on them. So I'm going to have to do 4 squared, and that's going to be 16. We'll go ahead and write that. But when we do a variable with a power, we multiply those. So this will be x to the 6th power and y to the 10th power. All right, same thing over here. We're not going to do 2 times 3 and get 6. All right, we have to do 2 to the 3rd power. So that's going to be 8. And then we'll have x to the 3rd power, y to the 21st power. And then we will go ahead and multiply this out. Now, off the top of my head, I'm not sure what 16 times 8 is, so I'm going to do that on a calculator. All right, now we're not allowed to use scientific calculators for this, but a 4-function calculator would give you this. So that's 128. And then as I'm multiplying these variables, I'm going to add the exponents. So this will be 9, and this will be y to the 31st power. So this would be your answer to number 15. All right, number 16. Do not cancel out these 5s and make a 1. That's a common mistake I've seen. Anyway, what I will do, we've learned that anything with a negative exponent is basically going to move to the other side of the fraction. So this 5 to the negative 6th power is going to move down, and this 5 to the negative 4 power is going to move up. So this is going to become 5 to the 4th power over 5 to the 6th power. All right? Now, I know that this is going to be 1 over 5 squared, and that's going to be 1 over 25, because if it's squared or cubed, we're going to go ahead and do it out. So that's going to be the final answer. Now, if anybody is not 100% clear on how I got 1 over 5 squared, just remember, 5 to the 4th power is 5 times 5 times 5 times 5. 5 to the 6th power is 5 times 5 times 5 times 5 times 5 times 5. So these four fives are going to cancel out these four fives. That's going to leave two fives in the denominator. That's why I have 5 squared right here. Okay, now moving on to number 17. Okay, I'm going to fix anything that has a negative exponent right away. So what, there's a bunch of things I could do, but one thing I can do is move this 4 to the negative 2 power down and make it positive. So this is going to wind up being 4 squared in the denominator. Okay, so that's the move I'm about to make. And in fact, because it's squared, it's going to be 16 in the denominator. So that happened. Meanwhile, up here, I've got these variables with the power 5. So this will be x to the 5th power, y to the 5th power. Okay, now I've got this. Now, again, I'm multiplying these when you do a power to a power. So this will be negative 10 and y to the 6th power. Okay, now anything to the 0 power is 1. So this entire set of parentheses has a value of 1. So I don't need to put times 1 right here because anything times 1 is just itself. So at that moment, I just have this. Now, of course, anything with a negative exponent is going to move to the other side of the fraction. So this is going to have to move up and become x to the 10th power. It's going to move. So recopying what I already had in the first place, all right, I had my x to the 5th power and my y to the 5th power and my 16 and I had this y to the 6th power, all right, but this x to the negative 10th power is going to go up. And so I've got x to the 10th power up there now. All right, so now I have this. Now it's time to simplify some more. Now these x's are up here together and whatnot. So I might as well put them together. So that gives me x to the 15th power. I'm adding those exponents. And that's y to the 5th power over 16 y to the 6th power. All right, now it's time for the final answer. So I will have x to the 15th power over 16. Now these 5 y's are going to cancel out 5 of these y's and just leave a single y. So my final answer here is going to be x to the 15th power over 16y. Okay, that was a lot of work, but you guys can handle it. So that was your answer number 17, and why. Okay, let's move on to number 18. And again, guys, these problems are like puzzles that we have to solve. There is more than one way to do this. So if you do it in a different way and you're getting the same answer that I'm getting, then whatever you did was surely fine. Okay, so let's analyze and see what we've got here. All right, so part of my thought process is I'm looking at the parentheses and seeing what I can get rid of. So really, you know what? These parentheses up here in the numerator just are not doing anything. There's no exponent here on the parentheses, so there's really no need for the parentheses even to be there. So what I really have is just x to the 4th power, x to the 3rd power, y to the 5th power, x to the negative 6th power. The parentheses were irrelevant. Now down here I see some parentheses. But here I have a power raised to a power, which you know I'm going to multiply. So that's going to make y to the negative 6th power. And then I have the rest of it here. So x to the negative 5th power, y to the negative 2 power. So now my parentheses are all gone, which is a good thing to do first. Now I'm hunting for my things that are the same. Now it would be a good time to put together anything that's the same in the numerator and the denominator. So for example, the x's in the numerator. All right, so I've got this, this, and this. I can put those together now. I'm just adding the exponents. So I've got 4 plus 3, that's 7. Then minus 6, that's 1. So that means I've got x to the 1 power, or just x. And that leaves y to the 5th power. So there you go. Now I'm looking at the denominator, and I'm looking for what's the same. Well, I've got y to the negative 6 power, y to the negative 2 power. So I can put these y's together. All right, I'm going alphabetical. So I'm going to go ahead and keep my x to the negative 5 power. Just bring that down. But I'm going to put these together. Now, negative 6 plus negative 2 is negative 8. So this will be y to the negative 8 power. Okay, so to review, I got rid of my parentheses first. Then I combined anything that's the same variable in the numerator and the denominator. And now my third step will be to deal with my negative exponents that's survived. And we know that anything with a negative exponent is going to move to the other side of the fraction. Okay, so both of these have negative exponents. So both of these are going to wind up moving. So this needs to go up. So I'm going to wind up with x to the 5th power up there. And this needs to go up. So I'm going to wind up with y to the 8th power up there. So as you can see, I'm not going to have a denominator after this is over. So here's what I'm going to have. So really, okay, so I can just deal with this. So these are up now. So just ignore the yellow stuff in the bottom because I moved it up. So I can just go ahead and put this together and get my final answer if you don't mind. If you don't mind, so if I have x to the 5th power times x, that'll be x to the 6th power, putting these together. Y to the 5th power times y to 8th power, that is y to the 13th power. It's adding those exponents. And that, my friends, is the final answer. Okay, that was fun. All right. So am I a nerd? Yes, but if you can put your brain in the right frame of mind, math can be fun. It's a puzzle. It's a game. Don't think of it as work. Try doing some math problems in your leisure time. I know I enjoy that. So anything to the 0 power is 1. So this problem looks really ugly, but you know, it's really not that bad. So, because this entire numerator is just 1. So that gives me 1 over whatever else I got. Okay. Now, be careful right here. All right, just to emphasize this, I've got negative 3 to the 4th power. This negative is not included with the 4. There's no parentheses. Okay, so this negative will not be affected by the 4th power in any way. So that means, what does that mean? That negative sign just is not going anywhere. Okay, so I am going to do the negative 1 power to all of these things. That means I am going to multiply all these by negative 1. So that means I'm going to have negative, like I told you, the negative's not going anywhere. So I'm going to have 3 to the negative 4 power, and a to the negative 5 power, and b to the positive 3 power, and d to the positive 2 power. Okay, now I've raised everything to the negative 1 power. Now, what about the negative sign, if you want to know? remember, you can think of that negative sign as a -1 if you want to. All right, sometimes it's helpful to think of a negative sign as a -1. So what happens if I do -1 to the -1 power? Nothing. -1 to the -1 power is still -1. Okay, think about it. If I do 3 to the -1 power, it drops you to the bottom, so it would become 1 over 3. Okay, the -1 power just does the reciprocal, really. 3 becomes 1/3. But if you think about it that way, what's the reciprocal of -1? Well, this -1 over 1, right? If I do the reciprocal of that, it's still, 1 over -1. It's the same thing. Either way, you're going to get -1. So that's why the negative sign was not affected. Just in case you were wondering. I know you're asking yourself, what about the negative sign though, Burton? Isn't it going to change to a positive? No, we're not doing -1 times negative. We're doing the reciprocal of -1, which is still -1. Anyway, now I'm just looking for anything that has a negative exponent because I know that needs to go to the other side of the line. Okay, so I know that this is going to go up. So I'm going to have 3 to the 4th power up there, and this is going to go up. So I'm going to have a to the 5th power up there. Is the negative sign going to go up with the 3? No. The negative sign is separate from the rest of it. So the negative sign is going to stay put. Okay, so up in the numerator, now I have 3 to the 4th power and a to the 5th power, like I said. I don't need the 1 anymore because 1 times this stuff is itself. Now, back in the denominator, I have that negative sign I keep talking about, and I have b to the 3rd power and d squared. And you know what? That's the final answer. All right, there are no more variables in common that I can cancel out or anything. So that's it. I happen to know this is 81. But we've decided that if it's 4th power or higher, we're just going to leave it. So I'm just going to leave it. Okay, let's move on to number 20. Okay, isn't this fun, guys? This is awesome. All right, I know you're having a good time. Now, the negative sign in front, again, is not going to be affected by this 4. All right, it's not in parentheses, so just leave the negative sign alone. Leave it alone. So my first job is to get rid of these parentheses. That's job number 1. Now, this set of parentheses didn't need to be there in the first place. There's no exponent on here. So why are there parentheses? We don't need them. Okay, so I have 3 to the 4th power. These parentheses are not needed, so that's just x squared y to the -2 power. Now these parentheses have a purpose because I have this exponent. So I'm going to execute the exponent. Now, is this going to be 8 or 16? It is going to be 16, please, because we're doing 4 squared. This is a regular number, not an exponent. So I have to square it. So this will be 16, not 8. But this is an exponent, so I'm going to multiply that. So I'm going to get y to the -2 power. These parentheses have a purpose as well, again, because I have this exponent. So I'm going to have x to the 15th power and y to the 6th power. These parentheses don't have a purpose. There's no exponent here that I have to worry about. So I'm just going to write down x to the -8th power because the parentheses were not relevant in the first place. Now I'm going to scan across here looking for things that I can put together. For example, I've got x here, I've got x there, and I've got x there. Okay, so let's see, I've got -3 to the 4th power times 16. All right, that's interesting. Not sure exactly how I'm going to deal with that. But anyway, the variable. So with these x's, I'm adding all of these now. So I've got 2 plus 15, that is 17. And then I've got minus 8. So 17 minus 8 is 9. So that's going to give me x to the 9th power. Okay. Now I am looking at the y's. So I've got y to the negative 2 power, another y to the negative 2 power, and I've got y to the 6th power. Negative 2 plus negative 2 is negative 4. Negative 4 plus 6 is 2, positive 2. So that's y squared. Okay, so I'm contemplating leaving this as my final answer. I've been told that I can leave the 4th power, and then 16, you know, I know that, for example, 16, I can think of it as 2 to the 4th power or 4 squared. Both of these things equal 16. These aren't like bases even with the 3. So I would accept this as a final answer based on what we've done in class. Now, if I wanted to, because it wouldn't be too bad, 3 to the 4th power is 81. Okay, I happen to know that. So I could do 81 times 16 on a 4-function calculator pretty easily. So I'm going to go ahead and do that just for fun. So 81 times 16 is 1,296. Okay, so I could put negative 1,296 x to the 9th power y squared. All right, if you're, you know, my OCD was just, this is bugging me a little bit. So I would accept either one of these as an answer. Okay, almost done. Problem number 21. Okay, this looks ugly, but you know, I like a challenge, and I'm sure you do too. Where do we begin? I would like to get rid of all of these parentheses. That's really my first goal. So this doesn't have parentheses right here, so I can just go ahead and bring down my 3x to the negative 5 power. Now here I've got the negative 4. So there are a couple different ways to do this, but one way is just to go ahead and multiply both of these exponents by the negative 4. So that would give me x to the negative 8 power over y to the negative 4 power. Okay, now here I've got parentheses and a bracket. So that's happening. So one thing I can do, if I sort of work from the outside in, dealing with the bracket first, you're going to wind up multiplying this. So this is going to give you, okay, so if I just redo this real quick. So I have x, y to the negative 2 power over y. Now, negative 3 times negative 2 is positive 6. So actually, I don't know why I put this bracket, because once I do that, then I won't need the bracket anymore. So now I've got this. Okay, now I'm going to come back to the main problem. So I could do all three of these things to the 6th power. So that's going to make this x to the 6th power, y to the negative 12 power, over y to the 6th power. So I just did the power of 6 to everything. Okay, already this is looking a lot better, a lot less scary. Now, you know what would also make this seem less scary? If I didn't have all these separate expressions, all right? It looks like I have 3 different things, but I really don't. This is really, when you're multiplying, you don't have to think of it as separate things. This is really like having one big fraction. All of these things are in the numerator, and these things are in the denominator. Okay, so let's look at it that way. So now it's time to put together any of the variables that are the same. For example, I'm looking at the x's here. So I've got x's, x's, x's. Let's put those together. So I'm going to have 3. Of course, I'm going to add all these. So negative 5 and negative 8, that's negative 13. Negative 13 plus 6 is negative 7. So I've got x to the negative 7 power, and then I've got my y to the negative 12 power. All right, of course, these are the same. They're both y's. So negative 4 plus 6 is 2. So that's going to be y squared. Okay, now it's time to deal with the negative exponents. Anything with a negative exponent needs to move to the other side of the fraction bar. So these two things have negative exponents. So that means this is going to drop down. So I'll have x to the 7th power down here, and this is going to drop down. So I'm going to have y to the 12th power down there. So as I recopy stuff, so the 3 and the y squared did not move. But like I said, I have x to the 7th power and y to the 12th power. So now it's time for the final answer. All right, that x to the 7th power is the only x, but I've got these two y's, so add those exponents, so that will be y to the 14th power. And that is the end of that, my friends. So that's the answer number 21. All right, last problem. Okay, number 22. Okay, number 22. First goal is to get rid of the parentheses that I see. So I'm going to do negative 4 power to everything in here. So I'm multiplying. So that's going to give me g to the positive 16 power, h to the negative 20 power, h to the positive 12 power, and g to the negative 24 power. So I multiplied all those exponents. All right, I'm not going to write this as a separate fraction. I understand that these numerators all go together. So I'm just going to go ahead and write my g squared right here. And I will bring down my g to the 5th power, h to the negative 7 power. So this is what I have now, no parentheses. Now it's time to put together anything that has the same base. So, for example, these go together. So when I recopy this, adding these exponents, I'm going to have g to the 18th power, h to the negative 20th. Okay, now looking at the denominator, all right, let's see. I've got these g's right here are going to go together. So negative 24 plus 5, that's negative 19. So I've got g to the negative 19 power. And then I've got the h's. All right, I'm going to put these h's together. 12 minus 7 is 5. So this is going to be h to the 5th power. All right, and now it's time to deal with my negative exponents. All right, this has a negative exponent and this has a negative exponent. So that means this is going to go up. So I will have g to the 19th power up there. And this is going to drop down. So I'm going to have h to the 20th power right there. Okay. All right, so again, let's see. So my g to the 18th power didn't move, and my h to the 5th power did not move. Okay, but now I have a g to the 19th power that's up here, and I have an h to the 20th power that's down here. So now I'm just going to put these together. All right, and I'm just adding. So 18 plus 19 is what? So I've got g to the 37 power, and of course 20 plus 5 will give me h to the 25th power. And that is going to be the final answer for number 22. That is a thing of beauty, my friends. And we're done.